Now let us see how to insert n geometric means between two given numbers a and b. Now this is analogous to what we have seen in case of arithmetic means. So let us here also take the simplest example and then develop the formula. Let's consider that two given numbers are a and b, and we have to insert a single geometric mean, which we denote by say g1, right? Now it means that this particular sequence formed by a, g1 and b should be a geometric progression. That means if we multiply a with certain common ratio r, we should get g1, and when we multiply g1 with r again, we should get b. So that means if we multiply a with r square, we should get the final number b. Alright, so here it is the power of r that comes into picture as against the arithmetic progression where it is just the addition. Okay, but here it will be power because the geometric progression involves multiplication by the common ratio, right? So here it is clear that r square should be equal to ratio of the last term upon the first term, so which in turn gives us r is nothing but square root of b by a, so which I just write in slightly different way, that is in index form, that is b by a whole raised to 1 by 2. Alright, now let us see what do we get whenever we have to insert two geometric means between the given numbers, that is a, b, and here we have to insert two geometric means which is g1 and g2. So here you see you have r in three parts, that is r appears 3 times, and it is not difficult to see that r cube will be equal to b upon a. That is, if we want to take the ratio from end to end, that is from last term divided by the first term, that will give us r cube. So here therefore r turns out to be b upon a whole raised to 1 by 3. So we'll have to take the cube root of b upon a. So here also we see a particular pattern, that is whenever we want to insert only one geometric mean, it is the second root of b upon a, right? Whenever we want to insert two geometric means, it is the cube root, that is the third root. So that means the root number is one more than the number of geometric means. So therefore if we want to insert n geometric means, that is g1, g2 up to gn between a and b, so it is clear by the analogy and pattern that the common ratio required here should be n plus 1th mean of b by a, sorry, n plus 1th root of b by a. So that is nothing but b by a whole raised to 1 upon n plus 1. So this is the required formula, and once we get the common ratio using this formula, we can easily calculate all the required geometric means simply by multiplying the first term by r to get g1. Now to g1 you again multiply to get g2, and so on. Now similar to arithmetic means, let us see the property of geometric means, that is product of n geometric means between the two numbers a and b equals nth power of the single geometric mean between a and b. So this is very much analogous to what we saw in arithmetic means also. Now let us go ahead and solve one question based on inserting the means. So here we have to insert 4 geometric means between 3 and 96, right? So here first number is a, which is 3, the second number is 96, and within these two numbers we have to insert 4 means, so therefore n is equal to 4. Now we know the formula of r is nothing but b upon a whole raised to 1 upon n plus 1, correct? So therefore in our case we have r is nothing but b is 96 upon 3 whole raised to 1 upon 4 plus 1. Now 96 upon 3 is 32, and that is raised to 1 upon 5, and we know that the fifth root of 32 will be nothing but 2, because 2 raised to 5 is 32. So here we get the common ratio required to be equal to 2. Alright, so therefore now let us insert the means, that is the first number is 3 and the last number is 96. What do? Is we multiply 3 with the common ratio, which we found that it is 2. So 3 2s are 6. Again multiply by 2 to get 12. Once again multiply by 2 to get 24. And lastly we multiply by 2 to get 48. And we can confirm that when we multiply 48 by 2 we get the last number correctly. So therefore the required 4 geometric means are 6, 12, 24 and 48.